Hello, so these are 3 additional problems that I'm going to work out after reviewing section 2.3. So we just got through talking about equations, so this is like more on solving linear equations. So if you look at these 3 problems, they're on page 85 in the workbook, number 5, number 8, and number 9. And remember now, this is more on solving linear equations, so we want to pay attention to the solutions. If we look at number 5, the first step is that you want to make sure you can handle the distributive property here. So we have a set of distributive property here, and we have a set of distributive property on both sides of the equal sign. So now we're just going to do distributive property. 6 times b becomes 6b. 6 times negative 5 is negative 30. Make sure you keep track of your equal sign. This becomes 20 plus 6b. All right, so now we have variables on both sides of the equal sign, and I always talk about, taking care of these variables first. So if we subtract 6b from this side, remember we have to subtract 6b from both sides. So here is 6b minus 6b, that's 0. So we have negative 30 equals, this becomes 0 equals 20. And we know that negative 30 does not equal 20, therefore this right here is a no solution. That means that there's no solution to this equation, and we know it because of the solution that we have. Let's look at the second equation. 2x plus 4 equals 5 minus quantity 1 minus 2x. The one thing that I want to point out before I get started is that, remember, the coefficient here is going to be 1, and we're going to do the distributive property here. I want to make sure that you understand that this coefficient is 1. So if we rewrite the problem, we have 2x plus 4. That equals 5 minus 1, because negative 1 times 1, and negative 1 times 2x is plus 2x. And then we're going to combine like terms here. So we have 2x plus 4 equals 5 minus 1 is 4 plus 2x. You might notice that they're the same thing on both sides. So right now you can almost conclude that this is going to be the identity property. But if you want to take it a next step further, maybe you're going to subtract 2x from both sides. And then you have something 4 equals 4. 4 equals 4, that's true. 4 equals 4, that's true. So it's true. Sometimes you may call it the solution. They may have all real numbers. Solution, they may call it the identity. Or they may say something like infinitely many solutions. But more importantly, what this means is that it doesn't matter what number, what variable you put in here for x, it's always going to be a true statement, infinitely many solutions, all real numbers, identity, that makes it true. If we look at the third problem here, again now we have a fraction here, and we can always start with the distributive property here. Always start with the distributive property. Then we have x plus 7 halves, and that equals 10 minus 6x, using the distributive property. And we talked about multiplying everything by the least common denominator. And even though these numbers are small, let's go and multiply everything by 2. So why are we using 2? The only reason why we're using 2 is just so we can have a whole number and get rid of that denominator. So this becomes 2x plus 7 equals 20 minus 12x. Again, multiplying everything by 2 just to get rid of this denominator here. And then if we work with our variables on both sides, you add 12x to both sides. So this becomes 14x. You're combining these terms, 12 plus 2x plus 7 equals 20. This right here cancels, is becoming more and more like a simple linear equations. You subtract 7 from both sides. So you have 14x equals 13. The signs are different, you subtract. And again, always divide by the same sign coefficient. Divide by 14, and I'll just take it up here. So x equals 13 over 14. Final solution there. All right, thanks.